Okay, so let's talk about logarithmic functions. A log is related, it's like the inverse of an exponential function. So you can see on this part here, like if you have the log, they're equivalent to each other. Here, this becomes the power. See the power over here? The base of the exponent. And then we can call this the answer. And the answer is inside the log for this one. So you can write them interchangeably. The first exercises I want to do is interchanging them back and forth. Like for example, 3 to the 4th equals 81, and they tell us to write it as a log. Well, you can write log. If you take the first number, it's 3. I do a little circle to remember. 3 and then 81 equals to 4. Or you can remember that the exponent is always the answer in the log. And then the base is the little number. And then the other one is like the leftover. So like I'm going to skip this one and go to the exponent. So like on this one, you will write it as log base 10 of 1000 equals to 3. See, the exponent is the answer now. And then so this one would be log of 12 equals to 1. Now, if you're going to do the other way around, I again do the little circle. I start with the first number I see and then go around. So 1/2 to the -3 equals 8. And they're supposed to be true, so it's easy to check with your calculator. If 1/2 to the -3 is 8, then you did it correctly. Like this one, it would be 5 to the -3 equals 1 over 125. 6 to the 0 equals 1. And we're going to use that interchangeably to solve some equations. Write this equation in exponential form. Again, I used the little circle to remember, but you can also use the words. A to the S equals R. You could also use the words that I place over here on the definitions, and that if you're better remembering words and where the placement is, then you can do that as well. This one is an interesting one because it doesn't have a base. If you're missing a base on the log, it's base 10. Remember that. That's very important because you don't have it, so you do need to remember that. Now, your calculators usually have a little hint of it. Let me show you. Here's my Casio. You see where's my log? Here's the regular log, and look on top. It's a 10. So the base of log is 10. So that's another way to remember. So this one you will write it as 10 to the m equals u. Write the exponential as a log. So I write the log first, and then 9 becomes small. 9a equals to p. Again, the circle. This one would be log of 10 of n equals to y. Now, because the 10 is the common base, you could also write it as just log n equals y. And we know that if you're missing the base, that it's 10. Now with that, we can solve some equations. Like here, solve this one. So the first thing is change it to exponential form. So it would be 5 to the 6 equals u. And that already solves it for us. Just do 5 to the 6 in your calculator. And there you go. 15,625 equals u. 9 to the -5 equals to n. So this, if you put it in your calculator, it would be 159,049. This is different because the base is x. So it would be x to the 1 equals to 2. So because it's the 1 plus x equals to 2, because there's no power. 1 is just regular x. This one, find the log. Well, there's two ways to do it here. If you're using the Casio that I recommended, you do have this little corner button. If you click there, you will write 1/8, and you get the -3. If you don't, you're going to use the change of base. So you would do log of 1/8 divided by log of 2. The base, you put it on the bottom, and the log, you put it on top. And then you would use the regular log for it. And you still get the same answer. And that's if you don't have the Casio. If you have the Casio, you can just type it in that corner button. The same thing with something like this. Now, with something like this, what happens is, see how you have the base and this base? So then the answer ends up being just the power. If you have the same basis on this and this, it's just going to be the power. These ones are the regular logs, so every scientific calculator should have it. You should be able to put log of 10 million, and you get 7. And then when you put this one, you should get -5. Feel free to stop the video so you can write them in your calculator and check. But every scientific calculator, regardless if it's Casio or not, it should have log. So to use it. The natural log is one, it's a log, but it has a base of e, and you can see on my Casio, and you see the base e right there. That's the ln, and there on top you see the base. Now these are just from the calculator, so you would just put, like, if I put log 0.04 round to the nearest thousand, so -1.3 tenth hundredth thousand. ln, you also have that one in your calculator. It's this one. And you get the answer there. Seems like I have it wrong in the handout notes. If you printed those out, you may want to fix that. Seems that the approximation there is wrong for some reason. So it should be -0.223, which is wrong from what you have on the notes. And then the other one will be ln square root of 2. 347. So again, at any point, feel free to stop the video, pause it so you can check with your calculators yourself. Don't just trust that you'll be able to do it. And then here, when you have the ln and the e together, they kind of cancel each other out, and we're going to do a lot more of that with equations later. This one, you would get 25 times the ln and the e cancel, and you get 2/5. And this is another one where there's a mistake on the notes, because I think I just put the 2/5 when it should be 10. So we might want to correct that as well. Now, not to say that you cannot just put them in the calculator and get the answer, but those little details, knowing that the ln and the e always cancel, help when it's time to do equations in later sections. Not necessarily on this one, but in later sections, it will help. So that's why I am telling you this right now, even though you can just plug them in. Like, you could just plug in this one in the calculator as well and get the answer. But I need you to understand what is happening so that when we do equations later, you know, oh, okay, yeah, that happened. So like when you have the same base, 10 log doesn't have a base, so it's 10. They cancel each other out and you get that. Same thing here, the e and the ln together always cancel out and you're left with just a number. Same thing here. And that's important when we're solving equations later on. Now we have some additional examples here that are very similar to the ones I just worked out, so I will not go over them on the video, but if you have any questions on them, just feel free to let me know.